Hello everyone. In this video, I'm going to talk about the solution to the following equation. X to the power 3 minus 3x is equal to root of x plus 2. And I'm trying to find all the real values x such that it satisfies this equation. Okay, so let me rewrite the equation here. X to the power 3 minus 3x is equal to root of x plus 2. And the first observation that x must be larger than minus 2. And this is because the left-hand side is a real number, and so is the right-hand side. So for the right-hand side to be a real number, we must have uh, x larger than minus 2. Okay, sounds good. Now, what do we have here? The second observation, left-hand side is of degree 3, right-hand side is of, let's say, degree 1 over 2 or half. But the point is, on the left-hand side, I have a polynomial of degree 3, and the right-hand side, I have something like root x. And if I try to plot this, remember that this was the plot of x. This is the plot of x squared. And this is the plot of root x. And this is the plot of x to the power 3. So the point is, x to the power 3 grows faster than x to the power 2, and x to the power 2 grows faster than x, and x grows faster than root x. And this is the key observation here. So I'm going to move this here, change the color, and I'm going to write 1 over 2 here, x to the power 2. Sounds good? Okay, so this is the key observation. Left-hand side is a polynomial of degree 3, and right-hand side is a polynomial of degree 1 over 2. So that basically means this is like just an observation. I haven't proved it yet, but this is the observation. Let's call it a guess. Could be a good guess for some, let's say A, for all x larger than A, the following must hold. And the claim is 3x is larger than root of x plus 2. So I'm saying that after some threshold, we must have the left-hand side always larger than the right-hand side. And the question is, what's the good value for A? And the reason that I'm trying to do this is to narrow down the range of x, right? I know that x is larger than minus 2. And here I also have x less than A. And from here, I know that x is between minus 2 and A. And then I would try to solve it for x inside this range, right? So what's a good value for A? Let's just look at what we have here. X to the power 3 and root of x plus 2. For x equal to 1, the left-hand side is negative and the right-hand side is positive. So I cannot have this inequality for x equal to 1. What about x equal to 2? For x equal to 2, I have x equal to 2 here. For x equal to 2, I have x plus 2 equal to 2, and also x3 minus 3x equal to 8 minus 6 equal to 2. So I have equality for x equal to 2. So I'm gonna make this guess that. So guess that star, let's call this star here, guess is that a star holds for a equal to 2. And okay, let me try and prove it. So on the left hand side, I have a polynomial of degree 3, and the right hand side polynomial of degree 1 over 2. And we can, if I want to show this, I want to show that a star holds for a equal to 2, a very simple approach could be as follows. I have this, and I'm going to say, okay, when exactly this is less than 2x? And I can see that this is valid for x larger than 2, right? Because if you simplify this, if you try to simplify it, you see that this is if and only if larger than, less than 2x, this is if and only if x is less than 2. And this is correct, right? So this is true for x larger than 2. Now I want to show that the left hand side, which is x to the power 3 minus 3x, is larger than root of 2x for x larger than 2. But I can make this one step easier. I can say that root of 2x is less than x x for x larger than 2. And the reason that this is true is because this inequality holds if and only if root 2 is less than root x, and this is true if and only if 2 is less than x. And this is also true. So I'm left to prove what? I'm left to prove that x to the power 3 minus 3x is larger than x for x larger than 2. And this holds if and only if x to the power 3 minus 4x is larger than 0. And this is true if and only if x to the power 2 minus 4 is larger than 0. And this is true if and only if x minus 2, x plus 2 is larger than 0 for x larger than 2. And this is clearly correct, right? Because all the terms I have here, I have 3 factors here. All of them are positive, so the whole thing must be positive. So that's it. I claim this bond here that for x larger than 2, I have the left-hand side larger than the right-hand side. So all I need to do is to search for x inside this bound where xa is equal to 2, right? And I also prepared a plot for these two functions. This is the Python code, and this is the plot that we have for these two functions. And as you can see, after x equal to 2, we have an equality, but after that, this fx, which is x to the power 3 minus 3x, is larger than root of x plus 2. Of course, if you're doing an exam, you cannot actually make these plots, but This is just to give you an idea why I made that argument about order of the functions that we have. I have something of order 3, I have something of order 1 over 2, and I know that after some threshold, which is being 2 here, the order 3 function must be larger than the order 2 function. And of course, I'm paying attention to the sign of these functions, right? I have x to the power 3. The sign here is positive. So this function is growing. Otherwise, it would have been decreasing. And so this argument, of course, wouldn't work. But here, this is positive, x to the power 3 with a positive coefficient. So this is growing, and this is also growing. And this is of order 3, and this is of order half. So f must be larger than g after some point. Good. Okay, now we are left with, so I know right now that x is between -2 and 2, and I know that the following holds. X to the power 3 minus 3x is root of x plus 2. Okay, so this fact that x is between -2 and 2 is begging for something that we all know from calculus. I can write x equal to the cosine of alpha for alpha between 0 and pi. So if I try it here, x is like cosine of alpha, this is alpha, between 0 and pi. And this is a representation that we can consider for x. Okay, so then I have what? Let me rewrite the whole thing that I have here using this representation. I have 8. Let me actually make this smaller a bit. I have 8 cosine of alpha to the power of 3 minus 6 cosine of alpha is equal to root of 2 cosine of alpha plus 2. And this is equal to root of 2 times 1 plus cosine of alpha. And this is equal to root of 4 cosine square of alpha divided by 2. Here I'm just using an identity that we know from calculus, that cosine of 2 beta is equal to cosine of beta squared minus 1. And I know that from calculus. This is a calculus fact. Let me resize it, make it a different color. So I'm using a calculus fact here. And the fact that alpha divided by 2 here is, and this is equal to 2 times cosine of alpha divided by 2. Notice that alpha divided by 2 is between 0 and pi over 2. So basically I have alpha divided by 2 inside this area, inside this region. So therefore cosine of alpha divided by 2 is positive. So the root of this number I have here must be a positive value, which is 2 times cosine of alpha divided by 2. It cannot be minus 2 times cosine of alpha divided by 2 because that would be a negative number. And I have, so I'm using this fact here. Okay. So now I'm going to cancel out a factor 2 from both sides. And that basically means I have 4 cosine of alpha to the power 3 minus 3 cosine of alpha is equal to cosine of alpha divided by 2. Therefore, I have this. Okay. But I know that this is another uh, equality from calculus, that the left hand side is equal to cosine of 3 alpha. So cosine of 3 alpha is equal to cosine of alpha divided by 2. So I have two values of cosine, cosine of 3 alpha and cosine of alpha divided by 2, and I know that they are equal. And the question is, what is the value for alpha? Okay, so the first observation is that 3 alpha is between 0 and 3 pi. And I know that alpha divided by 2 also is between 0 and pi over 2. So let me draw this here. So this is alpha divided by 2. And I know that 3 alpha produces the same cosine as alpha divided by 2. So 3 alpha, let's start from here. Let's start from here. This is 0, and this becomes like 1 alpha, then like 2 alpha, then 3 alpha, somewhere here, right? This is like the maximum range that 3 alpha can go. I cannot do another one and come back here. It's not possible because I know that 3 alpha is between 0 and 3 pi. So I have two choices. I have 3 pi, 3 alpha is either here or 3 alpha is exactly equal to this. Okay, so that's how we actually solve this equation here. So let me recolor this. Okay, and based on this observation, we have two cases. One of them is that 3 alpha is here, and one of them is that 3 alpha is right here. If 3 alpha here, then I need to go another alpha to make it like alpha divided by 2 plus 2 pi. So I have 3 alpha plus alpha is alpha divided by 2 plus pi. And so this is case 1, and for case 2, I have that 3 alpha is right here. So case 2 is 3 alpha is alpha divided by 2 plus 2 pi. And I have a mistake here. This is 2 pi. And from the first one, I can see that 4 alpha is alpha divided by 2 plus 2 pi. And from this, I can see that 8 alpha is equal to alpha plus 4 pi. And so 7 alpha is 4 pi. And from this, I can see that alpha is 4 pi divided by 7. Okay, that's solution. That's one of the solutions. And the other solution is that from here, I can see that 6 alpha is alpha plus 4 pi. And from this, I can see that 5 alpha is 4 pi. And from this, I can see that alpha is 4 pi divided by 5. So to summarize all we have discussed, we have found three solutions. X equal to 2, x equal to 2 times cosine of 4 pi divided by 5, and also 2 times cosine of what was the number I had? 4 pi divided by 7. And notice that for x equal to 2, we found this solution in the beginning, but we didn't find it here. And the reason for it is that this x equal to 2 corresponds to the situation where alpha is 0 here. So if I have alpha equal to 0 here, both sides would be equal to 1. which would be a valid identity, would be a valid equation for alpha equal to 0. So if alpha is positive, I have these two solutions, and if alpha is 0, I have this solution. And that's it. That's all the solutions that this equation has. Thank you so much for watching.